For now, our little Todo application built with a web API connected to a couple databases and web front end packaged into container images deployed to Azure. It works nice, but let's see if we can do something better. This is the second version of the app. Here is our web API connected to a couple databases and front end. But now what we have introduced during the development phase is, first of all, we added authentication, then we added a backend for front end and message processing service. So let's start from the authentication. Our current web app allows user to be authenticated and received or presented list of to-do items. In order to communicate with two independent web API, we created something what's called backend for front end, and our front end connected to a single entry point, which then redirects API calls to corresponding web API services. So in this case, authentication web API connected to its own little database of registration and verification. In our case, authentication web API built with a Node.js, and our authentication API built with a Node.js, and it has two web API endpoints, login and register. This web API packaged into Docker container image, which we then publish to Azure or to any deployment platform. So web connected to backend for front end, and BFF sends corresponding requests to all needed web APIs. This is our first improvement that we introduced, identity management service built with a different technology. Then we have backend for front end to communicate with all backend APIs. And today it's hard to imagine any application without using AI. In our case, our To-Do web app generates voice from the task description. In order to do this type of long running process communication, we have a message broker queue and long running service to talk with OpenAI to receive voice or audio files and then save everything into the database. Let's see how it works locally. So I'm going to build 5 container images and all infrastructure locally with Docker Compose. Let me start with a build script. For now, in my Docker, I have nothing. In Docker desktop, I have nothing running. But what I will do, I will start all infrastructure. All of this will be started locally for the application development and debugging. Let's wait for layers to be constructed and pulled if necessary. Okay, we have everything up and running. Let me check my Docker desktop. We have all databases, all message services, all web APIs, backend for frontend and frontend app started together locally for me for development. When I'm done with local development and debugging, what I can do, I can publish everything to Azure. In order to publish, I need rebuild my containers, then publish and restart web APIs. Let's see how it works. I can kill my local infrastructure. Once again, If necessary, I can rebuild containers and publish to Azure. Publish to Docker Hub in order for the Azure to pick up latest container images. While it's publishing, let's try to see what we have. This is our front end running from Azure. Let me see network communication. I can log in. We have communication with all our infrastructure through a single entry point backend from front end. Login API goes here, as well as tasks list. Let's create something. Let's say that this one we need to do now. Okay. Our post API goes to backend for front end. Let me remind. Front end goes to BFF. BFF goes to .NET Web API, which then saves data into storages, together with sending message to generate voice from the text using OpenAI. When voice is ready, it saves, it's recorded to database. And next time when we refresh list of our tasks, we see this little play button, which is
Rule the world with artificial intelligence.
Voice generated by the OpenAI. Like that. Let me create another one task. Like this. Save. Okay. Refresh in order to see when voice is ready.
Humanity does not behave intelligently enough and therefore cannot take care of itself.
Works awesome.